Hello and welcome to our manufacturing presentation for MCHE 3920. For this project, we were tasked with designing and manufacturing a part using a method covered by this course. Our team designed and fabricated a series of 3 differently shaped tree ornaments: a duck, a Lego figure, and a wrench ornament out of plastic using thermoforming as our chosen method. In this video, we will share our design and manufacturing processes, as well as the results and learning we obtained from thermofolding these parts. We will begin by discussing the basics of our chosen fabrication process. Thermoforming is a manufacturing method in which a thin sheet of plastic is heated and placed over a mold to form a part using a pressure difference. This process consists of heating the plastic, forming the material in or over the custom mold, cooling the material, removing the material from the mold, and then trimming it. We utilize positive vacuum thin gauge thermoforming, in which we create a vacuum on the mold side of the forming station, then applied air pressure on the non-mold side of the plastic to force the heated sheet over the mold. Most of our fabrication took place in the Driftmeyer fabrication lab, so we based most of our fabrication rules on theirs. We wore eye protection at all times, kept long hair up, and avoided any loose-fitting clothing. We also removed watches and necklaces upon entering the building. We wore gloves when working with the heat gun, and we made sure everybody stood clear of the process to avoid burns. We started with the most important part of our manufacturing process, the thermoforming table. We knew that if we couldn't get this to work first, then we'd have to scrap everything and start over. With that in mind, we looked into homemade thermoforming setups, and we quickly realized that this would involve some work. We narrowed down the size of the product we wanted to make, and we used those dimensions to design our table. It would be a hollow box with many small holes drilled into the top and one large hole on the side for a vacuum hose. We would use a heat gun to soften plastic above the table, and then press it over the object on the table. The vacuum pressure would pull the softened plastic over the object, creating a permanent impression of the object in the plastic. We originally planned on using a 3D printed object as our mold, but we were worried about the plastic object melting during the process. We chose to use a bulldog ornament that one of our group members had, but that went missing, and we had to change our plans. We decided to make a series of ornaments instead of the originally planned honey bottle, as our original plan had become unfeasible. The manufacturing process would have remained the same, but this plan made better use of our resources to create a better final product. The process of making the vacuum box was actually quite simple. Instead of buying materials, we found scrap wood and MDF board to make the sides, top and bottom, respectively. We drilled a vacuum hose hole on one of the sides, and then drilled several small holes on the top, and secured the box with wood glue. For the molds, each of our real-world parts, such as the duck, were cut in half. This reduced the chances of the plastic tearing during the thermal forming process. However, we needed to make 2 parts, one for each side. These parts were then joined using hot glue to make the final product. For the actual thermoforming process, we ended up using the plastic plates as our thermoforming material. One person with safety gloves on held the plate above the vacuum box and mold while the vacuum was on, while another person used the heat gun on the plate to soften it. Once it reached a point that was deemed soft enough, the person holding the plate quickly pressed it against the box and mold, which created the part. Finally, the part was trimmed using scissors and joined with its other half using hot glue. Our first attempt at thermoforming something was a failure. We tried to use portions of a red Solo cup for the thermoforming, but the plastic ended up being far too thick to conform to the shapes of the part. Because of that, we ended up using a very thin and cheap plastic plate as our material, which was far more appropriate for the thermoforming process. Also, we figured out that we had to be fairly precise with the amount of heat we used. Too little and the plastic wouldn't conform to the shape of the part, but too much and the plastic would tear from the suction of the vacuum. Applying heat to the plastic ended up being a balancing act, but in the end we got fairly good at applying just the right amount of heat to make the part. In addition to adjusting our material and heating techniques, we took several steps to increase suction by our air vacuum table. Initially, there was significant clearance between our vacuum hose and its corresponding holes on the vacuum table, allowing air to escape. This decreased the pressure difference on either side of the mold, and as a result, our plastic was not forming tightly enough over the mold. To correct this, we layered tape over the ends of the vacuum hose to decrease its tolerances with the vacuum table. Additionally, we added more small perforations across the top of the table to pull the plastic more tightly over the mold. There are several things that can be done to improve on future iterations. For one, in order to make a part, someone had to hold the plastic plate with gloves while another person heated it with a heat gun. While not the most dangerous situation, it's certainly not as safe as it could have been. An easy fix to this would have been making a wooden or metal holder so no one would have to actually hold the plastic directly. In addition, the material we used could have been better. Any plastic that was made for thermoforming would most definitely perform better than the blue plastic plates we used. Throughout the process of thermoforming our ornaments, we learned that design and manufacturing are iterative tasks and require experience-based improvements to create a quality end product. We identified the safety measures, materials, and techniques required for effectively thermoforming, and adjusted our system until we could form sleek, detailed plastic forms over the mold. After successfully fabricating 3 ornaments with our system, we now have valuable first-hand experience and newfound knowledge about this technique in manufacturing.